Imagine detecting a cosmic laser that has been traveling through space for billions of years before reaching Earth, a beam of radio energy so powerful that it can still be detected from halfway across the observable universe. Recently, astronomers using the powerful MeerKAT Radio Telescope discovered one of the most distant and powerful examples of this phenomenon ever observed. The signal did not come from a spacecraft or alien technology. Instead, it came from a natural cosmic object known as a megamaser, sometimes described as a gigantic laser operating on a cosmic scale. To understand why this discovery is so extraordinary, we first need to understand what a cosmic laser actually is. On Earth, lasers produce concentrated beams of light by amplifying photons inside a controlled environment. In space, something similar can happen with radio waves instead of visible light. These natural amplifiers are called masers, short for microwave amplification by stimulated emission of radiation. Under the right conditions, clouds of gas in space can amplify radio waves in a way that creates extremely powerful and focused emissions. Normally, masers are relatively small and weak. They can form around young stars or inside dense clouds of gas. But sometimes the universe creates something much larger and more powerful. When entire galaxies contain enormous amounts of energized gas, they can produce megamasers radio signals millions of times stronger than ordinary masers. These gigantic emissions can travel enormous distances across space and still be detected by radio telescopes on Earth. The newly discovered cosmic laser is one of the most distant megamasers ever detected. The signal began its journey when the universe was far younger than it is today. At that time, galaxies were still forming and evolving rapidly, and collisions between galaxies were far more common than they are now. These violent galactic encounters can compress massive clouds of gas and dust, creating the perfect conditions for megamasers to form. Astronomers believe the newly detected signal likely originated from two galaxies. In the process of merging, when galaxies collide, enormous gravitational forces disturb their structure. Gas clouds slam into one another, stars are thrown into new orbits, and the centers of the galaxies can become extremely active. These chaotic environments create intense energy and dense molecular gas clouds, capable of amplifying radio waves on an incredible scale. The signal discovered by scientists traveled more than 8 billion light-years before reaching Earth. That means the light we detect today began its journey when the universe was only about 2/3 of its current age. By studying signals like this one, astronomers can effectively look back in time and observe how galaxies behaved billions of years ago. Detecting such distant signals would have been nearly impossible with older technology, but the MeerKAT Radio Telescope is one of the most sensitive radio observatories ever built. It consists of dozens of large radio dishes spread across the South African desert. Working together, these antennas act like a single enormous telescope capable of detecting incredibly faint radio signals from deep space. When astronomers analyzed the data from MeerKAT, they noticed something unusual. Among the faint radio noise from distant galaxies was a powerful and extremely specific signal signature that matched the characteristics of a megamaser. The signal was far stronger than expected for its distance, suggesting that the cosmic event producing it must be incredibly energetic. What makes megamasers especially valuable to scientists is that they act like cosmic markers. Because they are associated with specific physical conditions inside galaxies, they can reveal important information about how galaxies evolve and interact with each other. By studying megamasers, astronomers can measure the motion of gas clouds, estimate the mass of galaxies, and even study the environments around supermassive black holes. In some cases, megamasers form near the centers of galaxies where enormous black holes reside. As gas spirals toward these black holes, it becomes compressed and heated, creating the perfect environment for maser amplification. These cosmic lasers can help scientists map the structure of the gas disks surrounding black holes with incredible precision. The discovery of a megamaser at such an extreme distance also suggests that these powerful phenomena may be more common in the early universe than previously believed. Billions of years ago, galaxies were colliding and merging much more frequently. These violent interactions may have produced many megamasers that we have only begun to detect with modern instruments. Our own galaxy, the Milky Way, contains smaller masers formed by star-forming regions and dense molecular clouds. However, the Milky Way does not currently produce the kind of massive megamaser emissions seen in distant galaxies undergoing dramatic mergers. Observing these distant cosmic lasers therefore gives scientists a glimpse into processes that rarely occur in our local cosmic neighborhood. Another fascinating aspect of this discovery is how it demonstrates the power of modern radio astronomy. Instruments like MeerKAT can detect signals so faint that they would have been completely invisible just a few decades ago. As technology continues to improve, astronomers expect to discover many more megamasers scattered throughout the universe. Future observatories, including even larger radio telescope arrays, will allow scientists to scan enormous portions of the sky with unprecedented sensitivity. These instruments may reveal thousands of cosmic lasers hidden among distant galaxies. Each new detection will provide another piece of the puzzle describing how galaxies evolve, collide, and grow over billions of years. Cosmic megamasers may also help astronomers measure distances across the universe with extraordinary accuracy. Because the signals come from specific molecular transitions in gas clouds, scientists can use them as precise reference points to calculate how far away their host galaxies are. This information helps refine our understanding of the large-scale structure of the universe and how it has expanded over time. The discovery of a cosmic laser from halfway across the universe is a powerful reminder that space is far more dynamic and energetic than it might appear. When we simply look up at the night sky, hidden within distant galaxies are processes capable of producing signals so powerful that they traveled billions of years before finally reaching our instruments. And somewhere in the vast darkness between the galaxies, countless other signals may still be on their way toward Earth. Radio waves created by collisions, explosions, and cosmic phenomena that occurred long before our planet even existed. Every new detection expands our understanding of the universe and reveals just how complex and mysterious the cosmos truly is. What scientists once believed were rare and unusual phenomena are now becoming key tools for exploring the deepest regions of space. As radio telescopes continue scanning the sky night after night, there is little doubt that more discoveries like this will appear in the data somewhere out there. Another powerful cosmic laser may already be shining across the universe, silently traveling through space, waiting to be discovered. As astronomers continued analyzing the data from the MeerKAT Radio Telescope, they realized that this discovery was not just about detecting a distant signal. It also provided a rare opportunity to study the environment of a galaxy billions of light-years away. Because megamasers are created under very specific conditions, they act like cosmic indicators that reveal what is happening inside distant galaxies that we cannot observe directly with ordinary telescopes. The particular signal detected by the MeerKAT array was associated with a special type of megamaser, known as a hydroxyl megamaser. These are produced by molecules containing oxygen and hydrogen, known as hydroxyl molecules, which exist inside dense clouds of gas in certain galaxies. When intense radiation from newly formed stars or active galactic centers passes through these gas clouds, the molecules become energized and begin amplifying radio waves in a way similar to how lasers amplify light. This process can create radio signals millions of times more powerful than typical masers found in star-forming regions. In fact, some megamasers are so strong that they can be detected across billions of light-years of space. That is exactly what happened in this case. The radio waves produced inside a distant galaxy began traveling through the expanding universe long before complex life appeared on Earth. By the time those signals finally reached our planet, they were incredibly faint. Yet thanks to the sensitivity of modern radio observatories, scientists were able to detect and analyze them in remarkable detail. The discovery highlights just how powerful modern instruments have become, and how much information they can extract from signals that are almost unimaginably distant. The galaxy producing this megamaser is believed to be undergoing a major transformation. Astronomers think it may be in the middle of a galactic merger, a process in which the galaxies slowly collide and eventually combine into a single larger system. During these collisions, massive clouds of gas are compressed and heated, triggering bursts of star formation and intense radiation. Such environments are perfect for generating megamasers. The dense gas clouds act as amplifiers for radio waves, while the enormous energy released during the merger provides the radiation needed to energize the molecules inside those clouds. The result is a natural radio laser powerful enough to shine across billions of light-years of space. Events like this are extremely important for understanding the history of the universe. Billions of years ago, galaxy mergers were much more common than they are today. Over time, Galaxies like the Milky Way gradually grew larger by absorbing smaller galaxies and merging with neighboring systems. By studying distant galaxies where these events are still happening, astronomers can observe the same processes that shaped our own galaxy in the distant past. Another fascinating aspect of megamasers is that they allow astronomers to measure the motion of gas inside galaxies with extraordinary precision. Because the radio emission comes from specific molecular transitions, scientists can detect tiny changes in the signal's frequency caused by the motion of gas clouds. These measurements reveal how fast the gas is moving and how it is distributed throughout the galaxy. This information can also provide clues about the presence of supermassive black holes. In many galaxies, enormous black holes reside at the center, containing millions or even billions of times the mass of the Sun. As gas spirals toward these black holes, it forms rotating disks that can produce powerful maser emissions. By mapping these emissions, astronomers can calculate the mass of the black hole and study how matter behaves in its extreme gravitational environment. The discovery of distant megamasers also plays a role in measuring the expansion of the universe. Astronomers use different methods to determine how fast the universe is expanding, and masers can provide extremely accurate distance measurements. Because the signals originate from specific molecules under well-understood physical conditions, they can serve as reliable cosmic distance markers. Each new megamaser discovery therefore helps refine our understanding of the universe's structure and its rate of expansion. In the future, astronomers hope to use these cosmic signals to create more precise maps of the universe and better understand how galaxies formed and evolved over billions of years. The discovery made with the MeerKAT telescope is likely just the beginning. As radio astronomy technology continues to improve, scientists expect to detect many more megamasers scattered throughout the cosmos. New telescopes and larger antenna arrays will be able to scan enormous areas of the sky much faster and with far greater sensitivity than ever before. One of the most exciting future instruments will be the Square Kilometre Array, which is currently under development. When completed, it will become the largest and most powerful radio telescope ever built. With thousands of antennas spread across vast regions of the Earth, it will be capable of detecting incredibly faint radio signals from the earliest galaxies in the universe. With instruments like this, astronomers may soon uncover hundreds or even thousands of megamasers located across the distant universe. These discoveries will allow scientists to study galaxy mergers, star formation, and black hole activity on a scale never before possible. But perhaps the most fascinating part of this discovery is the realization that signals like this have been traveling across space for billions of years before reaching us. The radio waves detected today began their journey when the universe was still young, long before our solar system formed and long before life appeared on Earth. Somewhere deep inside a distant galaxy, clouds of gas were energized by intense radiation and began amplifying radio waves into a powerful cosmic beam. That beam traveled silently across unimaginable distances through the darkness of space, passing through countless galaxies and cosmic voids. And after billions of years of travel, it finally arrived at our planet, where a group of scientists studying data from a radio telescope noticed something unusual hidden within the noise of the universe. A natural cosmic laser shining from halfway across the observable universe. Discoveries like this remind us that the universe is far more dynamic and energetic than it might seem when we look up at the night sky. Behind the faint points of light visible to our eyes lie enormous galaxies, powerful collisions, and cosmic phenomena capable of producing signals that travel across billions of light years. Every time astronomers detect one of these distant signals, they are not just observing a point in space, they are witnessing an event that happened billions of years ago, a message carried across time by the laws of physics. And as new telescopes continue to scan the sky, it is almost certain that many more of these extraordinary cosmic signals are still waiting to be discovered. As research into these distant megamasers continues, astronomers are beginning to realize that they may represent one of the most powerful natural amplifiers in the universe. The discovery made with the MeerKAT Radio Telescope suggests that many more of these cosmic radio beacons may exist in distant galaxies, hidden among the enormous structures of the universe and waiting to be detected. One of the most remarkable things about megamasers is that they allow scientists to observe regions of space that are otherwise extremely difficult to study. The centers of galaxies are often filled with thick clouds of gas and dust that block visible light, making them nearly impossible to observe with traditional optical telescopes. However, Radio waves can pass through these dense clouds without being absorbed. This allows radio telescopes to peer deep inside galaxies and reveal structures that would otherwise remain invisible. Because of this property, megamasers can act like natural probes of the most extreme environments in the cosmos. When astronomers detect these signals, they can use them to map the motion of gas clouds, study star formation, and investigate the activity around supermassive black holes. In some cases, the signals even allow scientists to measure the rotation of gas disks around black holes with extraordinary precision. Understanding how these systems work helps researchers answer one of the biggest questions in modern astrophysics: how galaxies grow and evolve over billions of years. The universe today looks very different from how it did shortly after the Big Bang. Over time, small galaxies merged together to form larger ones, stars formed and died, and massive black holes grew at the centers of many galaxies. Observations of distant megamasers provide a direct window into that earlier period of cosmic history. Because the signals we detect today began their journey billions of years ago, they effectively show us what the universe looked like in the distant past. Every new megamaser discovery therefore acts like a time capsule, carrying information about conditions that existed long before our solar system formed. Astronomers believe that many of these megamasers are associated with galaxies experiencing intense bursts of star formation. When galaxies collide, enormous clouds of gas become compressed and begin forming stars at extremely high rates. These regions can contain thousands of massive stars forming at the same time. The radiation from these stars energizes nearby gas clouds and creates the conditions necessary for maser amplification. These processes release huge amounts of energy into the surrounding environment. Powerful stellar winds, shock waves, and radiation from newly formed stars interact with the gas clouds inside the galaxy. Under the right circumstances, these interactions create perfect natural amplifiers that produce the powerful radio emissions we detect as megamasers. The fact that scientists were able to detect a megamaser located billions of light-years away demonstrates just how sensitive modern radio telescopes have become. Instruments like the MeerKAT Radio Telescope combine signals from many separate antennas spread across large distances. By combining these signals using advanced computing systems, the telescope effectively becomes a single giant instrument, capable of detecting incredibly faint radio waves. This technique, known as interferometry, allows astronomers to achieve extremely high sensitivity and resolution. It enables researchers to detect signals that would otherwise be completely lost in the background noise of the universe. As computing power and telescope technology continue to improve, astronomers will be able to detect even fainter signals coming from even more distant galaxies. Future observatories will push these capabilities even further. One of the most ambitious projects currently under development is the Square Kilometre Array. When completed, this enormous telescope will consist of thousands of antennas spread across large regions of the Earth. Together, they will create a radio telescope with a total collecting area of nearly 1 square kilometer. With this unprecedented sensitivity, astronomers expect to discover vast numbers of previously unknown radio sources scattered throughout the universe. Many of these may turn out to be megamasers associated with distant galaxies, undergoing dramatic transformations. By studying these signals, scientists will be able to reconstruct the history of galaxy formation and better understand how the large-scale structure of the universe developed. The discovery of distant megamasers also highlights an important truth about astronomy. Many of the most powerful phenomena in the universe are completely invisible to the human eye. When we look up at the night sky, we see only a tiny fraction of the cosmic activity happening around us. Invisible radio waves, X-rays, and other forms of radiation are constantly traveling across space, carrying information about distant events occurring billions of light-years away. Radio telescopes allow us to detect these hidden signals and translate them into data that scientists can study. Each detection adds another piece to the puzzle of how the universe works. Over time, these discoveries help transform our understanding of the cosmos and reveal the complex processes shaping galaxies across cosmic time. Perhaps the most fascinating aspect of this discovery is the journey of the signal itself. The radio waves detected by the MeerKAT telescope began traveling toward Earth long before humans existed. They crossed unimaginable distances through intergalactic space, passing through regions filled with galaxies, cosmic dust, and dark matter structures. For billions of years, the signal continued its silent journey through the expanding universe. Eventually, it reached our galaxy, the Milky Way, and then passed through the outer regions of our solar system before finally arriving at Earth. At that exact moment, a network of radio antennas in the South African desert happened to be listening. Hidden within enormous streams of cosmic data, scientists discovered the faint signature of a natural cosmic laser, shining from halfway across the universe. Discoveries like this remind us that the universe is filled with extraordinary phenomena, occurring far beyond the limits of human perception. With each new observation, astronomers uncover another layer of complexity in the cosmos, revealing that the universe is far more dynamic and mysterious than we once imagined. Somewhere among the countless galaxies scattered across the observable universe, many more megamasers are likely shining right now. Their signals are traveling across space at the speed of light, slowly making their way toward Earth, and perhaps, many years from now, another one of those signals will appear in the data collected by a radio telescope, revealing yet another hidden event from the distant history of the universe.